Alrighty, so this is class notes for section 9.3, special products. So what we're doing here in 9.3, what we saw in the 9.3 video notes, is that if we see a polynomial that is multiplied, so for example, if we see x plus 5 times x minus 5, and we notice that this fits the pattern of one of our rules, so this x plus 5, x minus 5 fits the pattern of a plus b, a minus b, then we can just apply the rule and find the values for a and b and plug them in to our solution according to the rule. So in the first example, our first term is the same. We have x as our first term in both polynomials, just like we have our first term as a in our rule. So a is going to be equal to x. And our second term in each of these polynomials is 5. We have x plus 5 and x minus 5, where in our rule we have plus b and minus b, so b is going to be equal to 5. So all we do to find our solution is plug in a equals x and b equals 5 into this formula, this rule here. The rule tells us our solution should look like a squared minus b squared. So you plug in x for a and you get x squared, plug in 5 for b and you get minus 5 squared. So the answer would be 25, or x squared minus 25. So let's do an example, number 2. Our first term in each of these polynomials is n, and our second term in each of these polynomials is a 1. And in one of these polynomials we are subtracting, and in the other we are adding. So we're going to use the rule a plus b times a minus b equals a squared minus b squared. Since our problem looks like this, two polynomials multiplied together with the same terms, just one adding and one subtracting, our solution is going to look like a squared plus b squared. So since n is our first term in both polynomials, a is going to be equal to n. And since b is our second term is 1, we have minus 1 and plus 1. B is going to be equal to a positive 1. So we plug these in, and we get n squared minus 1 squared, which is just equal to n squared minus 1. Looking at number 3, here we have only one polynomial, p minus 1, but that polynomial is squared. Remember, whenever we have x squared, it's just equal to x times x. It's x times itself. So when we have a polynomial squared, that is just the same thing as thinking of that polynomial multiplied by itself. So it'll be the same as p minus 1 times p minus 1. But instead of distributing and going through all of that work here, we notice that this fits the pattern of one of our rules. We have a rule that says a minus b in parentheses squared. So we have two terms, we're subtracting them, they're in parentheses and it's squared, so this does match our rule here. So a minus b squared is going to equal, or is going to look like a squared minus 2 times a times b plus b squared. So here to find our a from our polynomial, we're looking at our first term. So our first term is p, so we're going to plug in p for a. And to find b, we're looking at the second term. Our second term is 1. Now here it's minus b in our rule, so since we have minus 1, b is just going to equal a positive 1. When we plug this in to our solution, we have a squared, so we plug in p, we get p squared, minus 2 times, plug in p for a, plug in 1 for b, plus b squared, or 1 squared. So all we're doing is plugging these values in for a and b into our solution. We can simplify this to get p squared minus 2 times p times 1 is just minus 2p, plus 1 squared is just 1. Skip on down to number 6. We're going to do n plus 3 squared. So again, we have a quantity squared, or a polynomial squared, but we're adding our two terms, so our rule is going to be a plus b squared, and that is equal to, according to our rule, a squared plus 2ab plus b squared. So for a here, we look for our first term, so our first term is n, so we plug in n for a. Our second term is going to give us our b, so our second term is 3, so b is equal to 3. We plug in these values into the solution that we have from our rule, so a squared is going to give us n squared, plus 2ab gives us plus 2 times n times 3, plus b squared gives us plus 3 squared. We can simplify this to get n squared plus 2 times n times 3 is the same as 2 times 3, which is 6, times n, so we get plus 6n, plus 3 squared, which gives us plus 9. Last example we're going to do together is number 8. We have 2x plus 3 times 2x minus 3. So here we're going to use the formula a plus b times a minus b equals a squared minus b squared. Here, even though we have a 2 and an x in the beginning, that 2x is considered one term, so our a is going to be equal to 2x because we have a 2x as our first term in both polynomials. Our second term in each of these polynomials is 3, so since we have plus 3 minus 3, our b here is going to be equal to 3. So again, we plug both of these values into our solution. So we get for a squared, we take 2x squared. We're squaring the entire part that is equal to a, so the 2 and the x. So we put that in parentheses. Minus, for b, we just have 3, so minus 3 squared. Whenever we have an exponent and we're multiplying things inside parentheses, the exponent needs to be distributed as an exponent. So we get 2 squared times x squared minus 3 squared. We can simplify this to get 4 times x squared, or 4x squared, minus 9 as our final answer.